The following question is related to electrolysis, and the question states that concentrated aqueous sodium chloride is electrolyzed using inert electrodes. So the first thing is that the electrodes are inert, which means they're not taking part in the reaction. And the second thing is that it's concentrated aqueous sodium chloride that is being electrolyzed. Now this concentrated aqueous sodium chloride has one is the sodium ion in it, and the other one is the Cl-1 ion. So let me draw the sodium chloride ions. The positive ions would be attracted to the negative electrode. So I have the positive ion Na plus getting attracted to the negative electrode, whereas the negative ion Cl-1 would be attracted to the positive electrode, and there would be two more ions that would be coming from water. One would be H+1 ion and the other one would be the OH-1 ion. The OH-1 ion would be attracted, so the negative ions would be attracted to the positive electrode and the positive ions would be attracted to the negative electrode. Now the question states that which statement about this electrolysis is correct. Now the first one is that the chloride ions travel through the solution to the negative electrode. Now as you can see, the negative ion, Cl is in group 7, it's a negative ion. It's going to be attracted to the positive electrode, so it's not going to be attracted to the negative electrode. So this statement is incorrect. It should be attracted to the positive electrode. The second statement is that electrons travel through the solution to the sodium ions. The electrons never travel through the solution towards the sodium ions. The solution has ions. The only current that could flow would be in the form of ions in the solution. So electrons cannot travel through the solution, so this statement is incorrect. Option C is that gases are given off at both electrodes. Now this is what we can investigate, whether gases are given off at both electrodes or they're not given off at the electrode. So let's talk about this side first, cathode. At cathode I have two ions. One is the sodium ion getting attracted and the other one is the H+1 ion getting attracted. And the battery is sending electrons, so it's giving away electrons. The negative terminal is the one where the battery is sending electrons. So either sodium or H+1, they would be the ones that would be gaining electrons. Now to figure out whether H+1 is the one that's gaining electrons or whether it's Na plus that's gaining electrons from the battery, the electrons coming from the battery, I need to look at the ease of discharge series or the reactivity series to figure out which of the two would actually end up gaining electrons. So I've written down this reactivity series, and the lower down in the reactivity series, the more unreactive the metal, the higher would be the tendency for the ion to gain electrons. So these lower down have a higher tendency to gain electrons, whereas the ones on top have a lower tendency to gain electrons. Now I have the competition in our case is between sodium ions and H+1 ions. If you look for sodium ions and H+1 ions, sodium is over here, whereas H+1 is over here. Now according to the ease of discharge series or the reactivity series, since H+1 is the more unreactive element, then it is going to have a higher tendency to gain electrons. So the reaction is going to be at cathode, it's going to be H+1, and that would gain an electron, and so that electron would be going, the battery would be sending that electron, and that electron would most likely be gained by H+1 ions, and it's going to form a neutral hydrogen atom. Now hydrogen is a diatomic molecule, so you would need two hydrogen atoms. So two H+1 ions would gain two electrons to form two hydrogen atoms, and they would get together to form an H2 molecule. And hydrogen is a gas, so at cathode a gas would be formed. On the other hand, at anode I have two ions, OH-1 and Cl-1, and the battery is trying to gain those electrons back. This is the positive terminal, so the battery is trying to gain electrons. So either OH-1 would lose electrons to the battery, or it's going to be Cl-1 that would lose electrons to the battery. So I've written the ease of discharge series for the anode as well. So the competition is between OH-1 and Cl-1. So if you look at OH-1, it's over here, and Cl minus 1 is over here. So according to the ease of discharge series, it's going to be OH minus 1 that would end up losing electrons. But remember that since it's a concentrated solution of aqueous sodium chloride, so only for concentrated solutions, it's always going to be Cl minus 1 that ends up getting discharged because of the higher concentration. So remember this, that Cl minus 1 is an exception. Whenever the solution is concentrated, it's going to be Cl minus 1 that ends up getting discharged. So the reaction would be that Cl minus 1 would be the one that would lose electrons to the battery. So Cl minus 1 has one extra electron, it loses that extra electron to form a molecule, an atom of Cl, but since it's also diatomic, so there would be two Cl ions and they would be losing two electrons to form two Cl atoms that would get together to form a diatomic molecule. And the Cl2 formed is also a gas. So in our case, a gas is being formed at cathode, and a gas is also being formed at the anode. So this option C, that gases are given off at both electrodes, is perfectly correct. There are gases being produced at both electrodes. And we can also confirm the last statement as being incorrect. The statement says that sodium is formed at the negative electrode, which is incorrect. Sodium ions are not getting discharged. It's actually the hydrogen ions. According to the reactivity series, it's the hydrogen ions that end up gaining electrons at the cathode. So this last statement over here, option D, is also incorrect. So option C is perfectly correct statement that applies to this question.